Hi Year 12 Maths General students. This is a lesson from Unit 3 of the Queensland Maths General syllabus on displaying and describing time series plots using Excel. So the lesson objectives in this lesson are describing time series plots by looking for identifying features within the plot. So we're going to look at trends, cycles, seasonality, irregular fluctuations and structural changes, as well as pointing out any outliers. And then secondly, we're going to look at how to construct a time series plot from given time series data using Excel. Time series data is just a special type of bivariate numerical data where the explanatory variable is always time, in hours, days, months, or years. And the purpose again is trying to establish whether there's some sort of causal relationship or association between time and the response variable in the scenario. When we graph time series data, we have a special sort of scatter plot called a time series plot. And it differs from a normal scatter plot when you graph it because we join all the points together with line segments over time, and this accounts for the continuous nature of the plot. What I've got here is an example on road fatalities over time, and it's looking at the effects of introducing different safety laws over time and seeing how they influence the number of road fatalities. And as you can see, as time progresses, there's a clear trend that we have decreasing road fatalities over time, which gives feedback to our authorities that there's some sort of evidence that efforts we're making, laws we're introducing to reduce road tolls have been effective. After you've composed a time series plot, it's really useful to point out any features that might be found within it that you can discuss. So the common features we look for in a time series plot include a trend, irregular fluctuations, structural changes, potential outliers, cycles, and seasonality. When I'm looking for a trend, this is a general increase or decrease over a significant period of time. And I can draw in a line of best fit to show that increasing or decreasing nature of the plot. These can either be singular trends within the time series plot, or you can identify different trends within the time series plot. Usually with real world data, we see a lot of irregular fluctuations, and they're just seen as unpredictable variations in your time series plots that can't be associated with systematic changes like trends, cycles, seasonality, or other structural change, including outliers. The fluctuations that we see can be smoothed out to give us a better picture on patterns within the time series plot, and we're going to look at mean smoothing techniques in the next lesson. Features such as structural changes, you'll see as some sort of sudden change in the established pattern within the plot. And there's usually an external event that's associated with that change. If a structural change does happen, you might have to come up with more than one model to describe what you're seeing in a time series plot. Another common feature is an outlier, and we know that from our statistical studies so far that there are individual values that just don't seem to belong or match any patterns present. Let's apply these to an example to visualize what we mean. When I look closely at this graph, I can see a couple of trends. So it looks like I've got a positive linear trend here. I've got another linear trend up here. Because of the jump up to here, to the next trend, I would classify this part as a structural change. So we've got a second trend up the top here, positive linear. I then go into a negative linear trend, and we have this data point that just doesn't belong, so I'd classify that as an outlier. So if I was asked to identify those trends, I would probably scribble all over the graph like that to show where they were. Two features we haven't addressed yet are the cycles and seasonality. Cycles are repeating periodic movements and fluctuation either showing a pattern of increase and then decrease, or vice versa, over a period of greater than 1 year. Cyclic patterns don't always have a fixed period. Some cycles repeat and some don't. Seasonality within a time series graph is also a periodic pattern, but it's a repeating period of a year or less. So you might have an up and down cycle of a month, a fortnight, a week, and these are affected by seasonal factors that occur during the year. And the other difference between seasonality and cycles is it always has a fixed or known period length. If we look at this example here, I can identify that there's a definite seasonality. So it looks like there's about 4 points within a season. So we have a up and down, up and down, up and down motion. Within that time series as well, I can spot a cycle. So I have 3 seasons of up and down, then it goes down again. 3 seasons going up and down, slowly increasing and going down again. 3 seasons going up and down, increasing, going down again. So you can see here I've sketched in where I'm observing these cycles occurring within the time series plot, and they look like they're approximately 13 months long, and they have a decreasing trend over time. Focusing now on the seasonality, it looks like within a year I have 3 seasons that have a period length of 4 months each. And you can see during the year, each of the seasons progressively has an increasing trend. The appearance of these seasonal or cyclic fluctuations are usually attributed to other influencing factors like weather, time of the year, might be like a holiday period towards Christmas, times of the day, could be any other type of influencing factor. And you can investigate the reasoning for these seasonalities or cyclic fluctuations. Alrighty, time to compose some time series plots. So we're going to use Excel to do this. We're going to start using a simple line with markers plot within Excel. We use this type of plot when we know there's going to be simple features within the plot. And then secondly, we're going to have a look at how we can use pivot charts for more complicated time series plots that involve seasonal or cyclic data. Okay, the first example, we're looking at temperatures recorded over a 3-week period during March in Brisbane. We need to construct a time series plot using Excel and then see if we can describe it by identifying any features we've looked at. So I'll get you to open up this Excel document and we'll go from there. Okay, similar process to creating a scatter plot. Select the data that you're interested in plotting, and we want to go to Insert, and we want to choose this one, Line or Area Chart, and Align with Markers. Alright, so this should be your basic chart. And we want to do things like put in an appropriate title and axes. So you can change the title by clicking on the box. Remember, we can add our axes labels in by clicking Chart Design, going to Add Chart Element and Axes Titles for your bottom, your horizontal and vertical axes. So your chart should be looking something like this. To add a trend line, just right-click on any point, go to Add Trend Line, make sure it's linear. And display equation and R squared value on chart. Okay, so hopefully your graph looks something like mine. You can see straight away that we have a presence of an outlier. And when we start going into like a thorough analysis of the data, you may want to include or disclude the outlier and show the effect on your model. Remember, your model is defined by this equation, and your R squared value, if you can recall, tells you how well those data points fit that trend line. At the moment, it's on about 5%. If you get rid of that outlier, you can just delete the bit of data that's affecting it. You can see it will just disclude that, and you'll notice that your model equation has changed, and your R squared value has increased, so it's got a better correlation. Now it's up to 27.3% correlation between the data points and the trend line, which still isn't great, but it's better than it was before. And this modified model would give you a more accurate view of the model over time. So that's something to think about when we're using our models. For now though, we'll pop that back in there because we're just trying to compose a time series plot. Alright, so I've just copied over the graph and put it as our response to part A. Part B wants us to look at features that we might be able to identify. So if I look within that time series plot, I would be pointing out there's an outlier. I have a fairly obvious decreasing trend. Decreasing linear trend. And you can see all of these irregular fluctuations everywhere. There's no seasonality, no cyclic behavior, so that's it in this case. I would sum it up by pointing out those three features I can see. In this second example, you're given some data on the residential primary energy consumption recorded from the years 2001 until 2005. And the way you presented with the data, it implies already that we have some sort of seasonality because it's given us quarters within years. Okay, so let's have a go at putting this together in Excel. Open up the Excel file and let's get into it. Okay, so whether you manually enter this data or you've got access to my Excel file, the first thing we need to do is if we created just a normal line graph, you can see that it does all sorts of screwy things with your data. So we don't want to use that method. What we want to use is what we call a pivot chart. Before we try and enter this data as a pivot chart, we need to tell Excel that each of these quarters belongs to that particular year. So you need to go through and tell Excel that. So if you simply drag it down, you usually have to put it into the next one so it recognizes the pattern. Okay, so once you've finished adding that detail in, let's reselect all your data and then go to Insert, Pivot Chart, and we want Pivot Chart and Table so we can see what we're doing. What you'll notice is that it wants to put it onto a new worksheet, which is a really good idea because you don't want to mess with your raw data. Okay, and then you'll get a blank table and chart that you have to build. Okay, so the place where you put these fields is quite important, and the order that you put them in. Because I want the year and quarter on the x-axis, I'll pop it in, I'll drag them down into these axis category place and make sure your years on top and the quarters on the bottom. Then we want to see the BTU in the sum of values. Okay, you can close that once you've done that. And at the moment, it's in a column graph form. So we need to change it to our nice line with markers. So if you pop up to Design, change chart type, go to Line, and we want line with markers. Okay, you can see a preview. You're on the right track. And there we go. If you don't want to see that, delete it. Then we'll go through and add all those polishing details like a title and labeling the axes. After you finish doing that, it should look something like this. I am interested because it's really hard to tell if there's any trends present. So I am interested in putting in a trend line to see what the general trend is. So we're looking for a linear, put equation on the chart. I can see because of the gradient, it's a gradient of negative 12.5. So that shows us that there's a negative trend within the data. You can see the R-squared value is very low, and that's attributed to the large seasonal fluctuations we're seeing there. So those data points do not fit that linear model very well. And in another lesson, we'll look at something called deseasonalizing our data, which will smooth that out and give us a better trend line to use in a modeling situation. Okay, so I'm just going to paste that back over to our question, and let's look at some features within our time series plot. Okay, so like when we were graphing it, I said by adding that linear trend line, we can confirm whether there's a trend present. So we can see a decreasing linear trend there. The seasonality is very obvious. We can see that each season has 4 quarters within one period length. So that can be tracked through the whole of the time series that we're looking at there. So within that particular grouping of data, you can see the beginnings of 4 and a bit seasons. You can see within the seasons themselves, there's a little bit of irregular fluctuations there, and there are no obvious outliers within that plot that you can easily identify. Make sure we document those comments. Okay, at the bottom of the class notes, I've just added in the instructions that we use to construct those plots. Hopefully this has been helpful in going over how to construct your time series plots and identify those common features within. Thanks, Year 12s.